Hi girls, today we will be doing the third part of linear function. So first of all, let's do some revision. So last lesson we talked about gradient. So gradient, revising gradient first. So first part, gradient equals to rise over run, and that is y2 minus y1 over x2 minus x1 if the point are given as x1, y1 and x2, y2. But it also can be defined as the tangent value of the angle of the line made with the x-axis on the top right side. Depends on whether it's positive gradient or negative gradient. Your theta should be acute or obtuse. Okay, so today we will be doing something again very related to gradient, that is equations of line. So the equations of lines has several forms. Actually, we'll be focusing on a lot of different equations. First of all, let's do the special cases. First one, a vertical line has an equation of x equals to a. Imagine this line passes through a. Remember, vertical line is there, it will cut the x-axis. Therefore, the equation has only x in there, because no matter what y value you take along this line, it always has an x coordinate of a. So therefore, vertical line x equals to a. Okay, and if you have a point in here, let's say a and b, doesn't matter what b would be, even though it's a and c on top of that, they always have the same x coordinates as a. Secondly, a horizontal line, on the other hand, has an equation of y equals to b, because it always cuts the y-axis at a certain point, which means it doesn't have x in there. And this is y equals to b. Oops, this point is b in this case. Okay, and same thing happen if I have a point here as a and b. Now this time, the only thing doesn't change is the y coordinates, which is b. A can be anything you want along the line, which is the x coordinates of the point. So those two are the special lines you actually need to memorize because they have a special form. Okay, now we have done this in year 9 and 10, well, especially in year 10. Now the next thing, we've also done it before. Now, but this is very, very important. You need to recognize this specific form of straight line. We will have two specific forms to represent a straight line. In other words, a linear function. That is the first one, gradient intercept form. So the gradient intercept form has equation y equals to mx plus b. So as we have always said, lowercase m is the gradient. And because by the name gradient intercept form, b is an intercept. But what kind of intercept? More specifically, it's the y-intercept. And we will talk about that in a minute, about intercepts, because when, this is just a recap. Oops. the y-intercept is obtained by when x equals 0. In other words, it is the point that the line cuts the y-axis. Remember, on the y-axis, all the x coordinates are 0. Therefore, we let x equal 0. On the other hand, oops, not fine. The x coordinate, the x-intercept is obtained by when y equals to 0. In other words, it's the point that the line cuts the x-axis. Again, x on the x-axis, all the y coordinates equals to 0. That's how we actually find it. Okay, so in this way, so that means if we have the gradient intercept form, a straight line going through like this, let's say, oops, I need to redraw this. The gradient is m, and the y-intercept has to be b. In other words, it cuts the y-axis at b. And imagine if we have a point here called x and y, using the gradient formula, this is 0 and b. So the gradient in this case is equals to y minus b over x minus 0. If you rearrange it, make x, y the subject, you get this formula. You use this formula a lot, so please do remember it, and do remember what does m represent, what does b represent. That's the gradient, and that is the y-intercept. Okay, so let's take a look at an example quickly. Write down the gradient and the y-intercept of the line y equals to 4x plus 5. Part B. Hence, find the equation of lines through a point P with coordinates 0 and 2, which are parallel to, and perpendicular to the line y equals to 4x plus 5. Okay, you might pause the video to copy this down, but I'll just continue. Now, first of all, we need to write down the gradient and the y-intercept of this given line y equals to 4x plus 5. Because it's already in gradient intercept form, the gradient here is 4 and y-intercept is 5. Okay, so gradient, y-intercept. Next one. Now, the next part we need is, take a look of this. Remember, any line can be represented by the gradient intercept form. Later on, when we're looking for the equation of a line, we just use one formula. But this particular case, because the given point is a y-intercept, you can see that is 0 and 2. This point lies on the y-axis. Therefore, this has to be the y-intercept of the line you're looking for. So first of all, the first part of part B, you're looking for a line that is parallel to this given line y equals to 4x plus 5 and passes through the point 0 and 2. parallel, it means they have the same gradient, which we have mentioned in the previous lesson. If you haven't remembered that, pick it up now. Since it is parallel, so therefore the gradient looking for equals to 4. Okay, so the gradient of the line we're looking for is 4. And then the y-intercept is 0 and 2. Therefore, the line we're looking for is y equals to 4x plus 2. Because that's a 2 and gradient is 4. It's the line required. Okay, part 2. Okay, now we need to find out a line that is perpendicular to y equals to 4x plus 5, which also passes through the point 0 and 2. In this case, the gradient you're looking for, which is, remember, perpendicular lines mean those two gradients multiplied together equals to -1. So the line you're looking for has a gradient of m2, and the given gradient for 4x plus 5 is 4. It's 4, which we have already found at the first part. Now using that, you can easily just write it down. Therefore, m2 is -1/4. So therefore, the line you're looking for has the gradient of -1/4 x plus the y-intercept, which is the same thing, 2. That is the line required. Okay, so this is just a typical way of using the gradient intercept formula. Sorry, the gradient intercept form. Remember, later on we will have a general way to find out the equation of a line, no matter what is the given condition. So therefore, don't panic. Next one. Now, we have introduced the gradient intercept form of a straight line. The next important form we use all the time in coordinate geometry is called the general form. The general form is not the same as gradient intercept form, which y equals to mx plus b, which y is on the left hand side, x on the right hand side. On the other hand, the general form, we put all the x and y on and everything on the same left hand side and leaving a 0 on the right hand side. And it has a form like ax plus by plus c equals to 0. Okay, now there's no actual restriction on ABC. They all can be positive or negative, but for convenient reason, just normal convention, we normally make A positive. Not saying when A is negative is wrong, but we just make it easier for us in this case. Okay, in other words, we're trying to make the coefficient of x as positive. Just a convenient way, but not 100% necessary. Okay, so from this, we normally transform from general form to gradient intercept form, or from gradient intercept form to general form as well. So we have to know both, and the skill is just making one the subject if you want. So here is an example. Let's take a look. Okay, let's find the gradient and y-intercept of the line L, which defined as 2x minus 3y plus 12 equals 0. Okay, now we'll come back later.